The problem is that there is a trapezoidal koi pond that is 10 feet in length for the top base, 8 feet for the bottom base, has a depth of 6 feet, and is 4 feet tall. It is modeled by the diagram shown here. The pond is being filled at a rate of 15 cubic feet per minute. At this rate, how fast is the water level rising when it is already 1.5 feet deep?
To solve the problem, first the equation had to be set up. The volume equation for a trapezoidal prism is V equals depth times height times the quantity of base 1 plus base 2, all divided by 2. The constants were then plugged into this equation. Depth, which is 4, times h, which is not plugged in at this time, times base 1, which is 10, plus base 2, 8, all divided by 2, which then comes out to the equation V equals 108h divided by 2. To solve for the change in height, you must first take the derivative of the change in volume. This would be dV with respect to dt is equal to 54 times dH with respect to dt. This then is 15 is equal to 54 times dH over dt, which when 15 divided by 54 equals 0.278 feet per minute, that would be the change in height with respect to the change in time. First, we cut out the pieces of our trapezoidal structure using an X-Acto knife and a shoebox, and now we're going to use Scotch tape to put it all together. After you've used the Scotch tape together, your trapezoidal prism should look something like this. After you have formed the liner around the trapezoidal prism, it should look something like this, and the inside should be almost completely taut so you do not lose very much volume.
In order to model the water rising in the koi pond, we took cardboard and attached it to a stick, and then took blue construction paper and put it on top of that, and then when moving it in the seesaw motion, you're able to move the water up and down.
To finish the model, add the problem as well as any directions to the model, and add construction paper and animals to decorate.